So let us try to understand what is Docker. Docker is a tool. Like I said, it's a tool which provides a containerization platform and helps in running the containers. Okay, it helps developers to pack the code along with its dependencies and ship it as a package. It ensures our application works seamlessly in any environment. We make sure it works on any environment. And then you can see the differences between the virtual machines and containers. Yeah, here you can see, right, this is a virtual machine 1, virtual machine 2, and virtual machine 3. See, let's first try to understand the architecture of virtual machine. Like we discussed this in the beginning, right? Now let's try to analyze it. See, this is your laptop, let's say, or whatever, host operating system like Windows. Okay, let's say this is Windows 10. Above this, you have hypervisor. What is a hypervisor? We have discussed about what a hypervisor is. What is a hypervisor? We have discussed this in the beginning.
It supplies the hardware or something.
Hypervisor is a software which allows you to create a virtual machines, which allows you to allocate resources to your virtual machines, right? Which helps you to manage your virtual machines like Oracle VirtualBox, Hyper-V, VMware, yeah, VM Workstation. These are all different examples of Hyper-V, a software which helps you to launch, to create, to relocate resources to the VMs. So let's say some VMware hypervisor we have used and we have created some virtual machines. Okay, this is some virtual machine. And if you see the virtual machine closely, every virtual machine will have its own operating system, which is called guest operating system. See this one. Every VM will have its own guest operating system, and this is called the host operating system. Okay, guest operating system sits above the host operating system. Okay, and if you notice here, we'll be allocating resources to these VMs. Those resources will be consumed again from the host only. Okay, maybe let's say you have allocated some 10 GB to this VM. Out of this 10 GB, majority of the GB will be consumed by the OS itself. Then the application. Let's say this app is the gaming app we were talking about. Okay, again the binaries and libraries like softwares required, some dependencies. Right, so if you notice here, every virtual machine will have its own operating system. Okay, the operating system works like it because it has got its own full-fledged operating system. It just works like a normal machine. Okay, it can start, it can shut down, it can boot. It just works like a normal machine. But because it has got its own operating system, it just is very heavy and huge. It consumes a lot of resources. You can see 10 GB we have allocated. Out of this 10 GB, majority of the GB is consumed by the operating system. Right? Similarly, suppose I have here only 40 GB. Okay, 10 GB to this. This is just an example number. The size vary depending on your virtual machine. So 30 GB consumed. Only 10 GB left for the host. Okay, if your host is having less resources, you cannot these virtual machines works drastically slowly. Putting too many virtual machines degrade the performance. They just hang up. You cannot just log in smoothly, right? It just takes time to reboot. The system just hangs up. Okay, so yeah. So they consume lot of resources. They are big. They are so huge. That's how virtual machine. But the guest operating system is irrespective of the host operating system. Means you can your guest like your virtual machine can have operate any operating system irrespective of the host. Okay, and here you need to notice a very important point. To run these virtual machines, your hardware should support it. Okay, I don't know how many of you have run the virtual machines in your local computer. If you have, you might be knowing this. Your hardware should support it. Means there'll be something like a BIOS, input output. You should go to the BIOS, enable an option called virtualization technology. By default, this will be enabled. But in case if it is not, you have to enable it. Then only you can start virtual machines. Means your hardware should support it. Okay, that's how virtual machines work. They are huge, they consume a lot of resources, right? Hardware should support working with virtual machines. That's about virtual machines. Let's talk about containers now. See, again, this is my Windows laptop. If you want to run containers, yes, Docker should be installed. Docker engine means Docker should be installed and Docker should be running. It's called Docker daemon. Above that, you can have a container. Okay, you can have your containers above that. And if you see here, you can notice the difference. Containers will not have the operating system, will not have their own operating system. Okay, because operating system is huge. They don't have their own operating system, but still they can start, they can work like a normal machine because they don't have their own operating system, but they will share the operating system of the host. Host means the system where they are running. They just share the operating system of the host. And because they don't have their own operating system, they are very light. They are light, they work really faster. Right? They consume very less resources. They are lightweight, they work really faster. They can start, they can shut down, they work really faster. Okay, and here the point is you don't need to go to your hardware and enable virtualization because here virtualization, I mean hardware, you don't need a hardware because this is containerization. Okay, you don't need a support from hardware here. That's what is virtualization is done at the OS level here. So you don't need any support from the hardware. Right? So now what is a container then? It's not having an, it's like a simple pack, okay? Or else think about a container. Container, what is the dictionary meaning of a container? What is the dictionary meaning of a container? It's nothing but a holder, right? A holder to put something. Same is the case. Container is nothing but like a holder where you put your app and dependencies of your app. Dependencies of my app are Java, Tomcat, or the dependencies. That's it. That's all is your container. It's just packing your application along with the dependencies. I'm sorry. It will not have anything beyond that. Just your application and the dependencies. That's why it is lightweight. It works really faster. It runs faster. It can be created on the fly. It can be created very easily on the fly, very quickly. Unlike VMs, you don't need a separate team to maintain, to create, to manage them. They can be created on the fly. And because they don't have their own operating system, they're they work really
Is
fast.
it possible to run all the containers, like multiple containers at one time?
Yeah, you can run multiple containers because see, because they don't have their own operating system, they consume less resources. Means you are short of resources, or else you are running out of resources, or else you have limitation on the resources. Like you have only 20 GB, you need to run some application. Containers would be the best option. Because see here, your operating system, you need to allocate a lot of resources for your all those resources were saved here, isn't it? So yes, you can start multiple containers on the fly very quickly, very easily. They consume less resources when compared with VMs because they don't have their own operating system, and you don't need a support from hardware. Okay, your containerization, your hardware need not support it. You don't need a support of virtualization technology enabled. It implements the concept of containerization.
But if one container, in case if one container needs more resources and the other one needs less, how does it manage?
See, actually, in containers, we don't allocate resources beforehand. But here, VMs, but for VMs, see, you need to allocate resources when you're creating them. Like 8 GB, 10 GB, you have to calculate the resources, assign them beforehand, before creating them. But here containers, we don't allocate resources. Containers consume the resources from the host dynamically depending on the need. Here in this container, you may be running a DB. Here you may be running some Java app. So depending on the application requirement, they'll consume the resources from the host. You don't need to allocate prior to it. Only whatever needed, those resources will be consumed. Got it?
Yes, ma'am.
Any questions? Let me ask you a question so that you can check your understanding, how well you have understood the concept. My question is, here I'm having my host operating system as Windows 11. Can I run a Ubuntu VM? Can I run some other version of Windows 2000 or whatever? Here,
Yes, ma'am, you can.
can I run another distribution of Linux? Were all these three VMs possible or not on my Windows 11 host?
I think it's possible.
It is possible because every VM will have its own operating system, which is independent of the host operating system. Yes, you can have a operating system of the virtual machine irrespective of the operating system of the host. Yes, possible. Then how about this? Let's say this is my Windows 11. I have Docker installed. Now, can I have some other version of Windows? Can I have some other Linux distributions? Which of them are possible? Were all these three possible or not?
No, I don't think so. This is possible with containers.
Why it's not possible?
Because it won't have the different operating systems, right? It will use the host operating system.
Exactly. It shares the operating system of the host. It doesn't have its own operating system. So a Windows container cannot share the operating system of Linux. Means they'll not have their own kernel. Okay, you if you take Linux, a Linux container cannot share the kernel of Windows. Simple. Again, here you may be having a question. You said that containers don't have operating system. How come you call it as a Windows container, CentOS container, Ubuntu container? Isn't it? See, Windows container or CentOS container means yes, it doesn't have its own full-fledged operating system, but binaries of CentOS, libraries of CentOS will be there. Not a full-fledged operating system, just the binaries and libraries will be present. Okay, that's what we are calling CentOS container. Don't get confused with it. So, meaning if it is Windows, you can have only Windows contents. Of course, different versions are fine. Windows, something like Windows 7 or 2000, whatever. Any versions are fine, but the base should be Windows. If you want to Linux containers, this should be Linux. Your host should be Linux. Host means the system where they are running. It should be Linux. Then, yes, CentOS is possible, Ubuntu, Red Hat container are also possible. Any distribution of Linux are possible because they share the kernel of this. Am I making sense? But let's say
So,
mine.
in real-time projects, do we like how do we choose like in between virtual machines and containers? Does it depends on project or?
Project depends on your application. Your application is Windows based or Linux based. Depending on that, you'll use the containers. And this is, let's say, this is Windows. I want to run Linux containers. Directly, I cannot run. I have installed Docker, but here I can run only Windows. What I should do? I can have another virtual machine running on my Windows 11, right? Like these virtual machines. I can start some virtual machine of Linux. On this virtual machine, I can install Docker. On this, I can start Linux containers. Following everyone? Yes or no will help me.
Yes, ma'am.
Yes, ma'am.
This way I can. Means virtual machines are still required. Isn't it? Virtual, that's what I told you in the beginning. Containers are not replacing VMs. You still need VMs. This is one of the purpose. Again, I need a VM. Where to run containers? Containers are like, again, like an application, like a package. In earlier, we used to share WAR file to deployment team so that they take that WAR file and deploy. But now we don't share the WAR file directly. We share the WAR file by adding Java, by adding Tomcat, and give that back. Means it's like, again, like a package. Tomorrow I'll elaborate on this part, how deployments happen with containers. So just today understand the concept. Okay, so now if I on my Windows I want Linux containers, means I'll have a Linux VM. On that I'll install Docker. Then this Linux VM becomes a host for these containers. Now this is the host. Docker host. Docker host means system where Docker is running. This is the Docker host. They'll share this kernel. And they'll share this kernel. So that way you can run.
Can we have like multiple of these, ma'am, like multiple VMs and on top of that docs?
Yes, this is what, right? Yes, on this you can run your containers. These blue boxes are containers. Yes, that's what.
So if you do that, like, is it will it put a lot of pressure on?
Because we came to this extent, let me tell you. So yes, VMs, VM1, VM2, VM3. On this hundreds of containers you can put. Okay. Now this is not your laptop. Okay. This is a physical server in your own data center. Physical servers means which are very huge, which can run many VMs. Above that you will be having containers. Got it now? You could run multiple VMs. On that VMs you'll have containers. Or else you don't want your own data centers. Companies will use AWS EC2 instances as a virtual machines. On these virtual machines, you'll be running containers. You may use 10 EC2 instances, any number. It's a data center of AWS. On that you will put thousands of containers. Got it now?
Yes, ma'am.
For your understanding, initially I told you this is like your operating system. Now make it scale up to your company infrastructure of your project of your company. So physical machine on which you have hundreds of VMs, on which you have thousands and thousands of containers. Or else you don't, company is not willing to manage their own data center. AWS EC2 instances on which you'll be running your containers. Why containers? You may be now having some confusion. Okay, when you are using AWS instances, why again container? You can directly put on AWS instance. You run a WAR file directly here. But let's say I want to run WAR file on 10 servers, 10 EC2 instances, which are again huge, costly. I need to pay for them. Rather, only one EC2 instance on that 10 containers. Isn't that sound great? So that it's very easy to create, it's cost effective. I can create with a single command. But again, creating EC2 instances also takes some time. I need to pay for them, right? Rather, only one EC2 instances on which I run 10 instances of containers where each WAR file is running, where each instances of my address book application, the WAR file is running. That doesn't sound great? Yes or no, or didn't understand any answers,
Yes.
I can accept it. But I just need some
Yes.
answers from you. Do respond, learn them carefully. This will help you a lot. If you understand these concepts, you will enjoy working on your projects. Otherwise, life becomes miserable. If you don't understand the basics, if you are sit in the project, it becomes very difficult. Learn them properly, learn them thoroughly. I believe you are all following. Okay, so
So is there any maximum number of containers that we can put on one virtual machine, ma'am?
no, like I said,
Do we have something like that?
containers dynamically consume the resources, right? So whatever resources present on the VM, they can consume. If they're short of resources, those containers will fail. No strict number, because there is no strict size of a container. Size of a container depends on what is present inside. So how many containers you can put on this virtual machine or you can put on this EC2 instance depends on the size of that EC2 instance again. If there are no enough resources, containers will fail. Got it? There will be no strict size of any virtual machine, isn't it? Same is the case. How many you can run on a VM depends on the size of a container, depends on the size of the VM. Let me put it diagrammatically. This is a VM. VM size is, let's say, okay, let us say it's a small, let's say 10 GB. Let's say you have one container, each 1 GB. So how many you can run? 10 containers. Of course, you need to leave some GB which is required for the VM. Just an example. Or else, let's say I have containers which consume each one 5 GB. You can run only 2 containers. Or else I have containers which consume 15 GB. It fails, it cannot run here. Okay, that all depends. But the concept is it consumes the resources dynamically from the host depending on the requirement. But you can put a limit. Like it can use only up to 8 GB. Containers can use only up to 8 GB. That limit you can put. But you don't allocate the resources beforehand. But still, you can put a limit on how much resources containers can consume on that VM. Clear?
Yes, ma'am.
See, these are the very, very important and very basic concepts of Docker. We didn't go actually deployments, we didn't talk about them. But unless you know these things properly, you cannot understand or you cannot enjoy learning. Okay, whether you go for Kubernetes or whether you go for anything, these concepts should be very clear with. We notice people start working in Kubernetes in the project directly without understanding these basics. Yeah, they may work, but when the actual problem comes in, means when something goes wrong, when you want to troubleshoot, if you don't know the concepts, you cannot fix the problems. It's not that you just create or deploy. After deployment, you should see it's functional. To do that, you need to know the concepts. All right, then, okay, we have understood what are VMs and containers. My request is don't ignore these topics. Learn them properly, learn them thoroughly, do hands-on. Okay, that's a help that makes the training fruitful. So we have understood the concept of what are virtual machines, what are containers. Tomorrow we'll go into the in-depth of the subject, when we should use a container. Okay, we have learned what are containers, what are VMs. So when to go for a VM, when to go for a container, because we understood that VMs are not replaceable. We still need them. So when to choose, like how to choose, whether I should go for a container or I should go for a VM. Okay, again, how development process change, how deployment process change with Docker. Okay, development, deployment with Docker, how they change, how Docker is helpful. Okay, we understood it's fast, it's quick, it's lightweight. But beyond that, what are the other reasons? Okay, we'll discuss all of them and then we'll start with the hands-on with Docker. That's all for today from my end. Any